Hey guys, it's Justin, and in this video we're going to be expanding our knowledge of how to solve equations by moving past those easy one-step equations and instead focusing on equations that require 2 steps to solve. This will prepare us to solve equations with any number of steps. So let's start with the same idea with the scale that we had before. In this case, we've got 2 x's plus 4 extra pounds that weigh the same as 12 pounds. How would we solve this? So let's just try undoing each operation. First up, the x is being doubled, so let's undo that using division. If you're wondering why we're also dividing the 4, just remember the scale. We aren't changing one piece of the scale. We're changing the entire left side and the entire right side. So when we divide, everything on the left gets cut in half. So if we divide everything by 2, we get x plus 2 equals 6. This is an issue because we only wanted to undo the multiplication, not change the 4 along with it. This is why we undo operations in a certain order, so we can make sure to only change one operation at a time. Remember when we discussed the order of operations, or PEMDAS? Well, that was for putting amounts together. What we're trying to do is take the amounts apart in order to find what one specific value is, which completely flips PEMDAS on its head, literally. When solving equations, we reverse PEMDAS to make SODMEP. I know it sounds funny, but it works. Imagine it like this. When you're getting dressed, you put your socks on before your shoes. Now your socks are stuck inside your shoes, and the only way to take them off is if you remove your shoes first. PEMDAS is putting the socks on before the shoes, and SODMEP is taking off the shoes so you can get to the socks. So let's go to our first example here and use SODMEP to pick apart this equation to figure out what x equals. Our first step in SODMEP is to undo the subtraction and the addition. So right there, that's going to be our 2x plus 4. And we can undo that with subtraction by doing a minus 4. Remember to do that on both sides. It's that golden rule. It's balancing the scale. The plus 4 and the minus 4 cancel each other out, leaving just 2x plus 0. And we don't need to write that down because it's 0. And 12 minus 4 equals 8. Our next step in SODMEP is to undo division and multiplication. We see 2 is multiplied by x here, so we're going to undo that by dividing both sides by 2. And once we do that, we will get x is equal to 4. Just like when we were solving one-step equations, it's super important to check our answer after we solve for x. As a matter of fact, it's even more important now when we're doing 2 and more step equations because there's more opportunities to make a mistake. So let's take our original equation, which was 2x plus 4 equals 12, and we will put in 4 for the value of x that we got. So that's 2 times 4 plus 4 equals 12. Now remember, we were using SODMEP to undo the equations, but now that we're putting it back together again, we're going to go back to using PEMDAS. So first things first, we're going to skip the parentheses and the exponents because you don't have those here, but we do have multiplication. 2 times 4 equals 8. That plus 4 does equal 12, which is exactly what we wanted. All right, let's move on to our next example. Negative 3x plus 1 equals 13. This kind of has the same ordering as the last problem. We're going to start by undoing the addition with some subtraction and minus 1 on both sides of the equation. Here, we're going to get minus 3x plus 0 because the 1 and the negative 1 cancel each other out equals 12. Once again, we have some multiplication to undo. So we're going to divide both sides by negative 3. This is another case where we're going to have to pay attention to the signs. The negative 3's cancel each other out and just leave us with x. But on the other side, we are going to have to change the sign because the second term is negative. 12 divided by negative 3 is negative 4. And once again, we should check our answers by plugging in the value that we got for x into the original equation. So in that case, it was -4. First up, we're going to do multiplication because that's the first in the order of PEMDAS, and it's -3 times -4. Once again, we're going to have to change the sign because the second value is negative. So that leaves us with +12 plus 1. And that, of course, is equal to 13. So -4 is correct. All right, last example for this video. X over 2 minus 5 equals 2. First up, subtraction and addition. This time we have subtraction, and we're going to undo that with addition by adding 5 to both sides. The -5 and the +5 cancel each other out, just leaving us with x over 2 equals 7. Now we could do this two ways. One, we can consider that x over 2 1/2 x, but then we'd have to divide by a half, which is confusing. So instead, we're going to treat this like division and use multiplication to undo it. We're going to multiply both sides by 2. This will cancel out the divided by 2 and leave us with x on the left side. And on the right side, we'll have 7 by 2, which is 14. All right, once again, for this last one, we're just going to check our answer by plugging in the value that we got for x into the original equation. So that'll be 14 over 2 minus 5 equals 2. All right, so we start with division first, going by PEMDAS. 14 over 2 is indeed 7. 7 minus 5 is equal to 2. So x equals 14 is correct. So remember, use PEMDAS when you're doing operations, and use SOLVEMAP when you need to undo operations to solve an equation, no matter how many steps it has. In the next video, we're going to continue to use SOLVEMAP to solve equations with even more steps.